Can you guys hear me all right? I don't know how long the delay is, so I don't know how long to actually sit here waiting for an answer. Hopefully I've got everything set up right for this. Right now I've got it locked to only stream my terminal window because I don't want to accidentally put my email up on stream or something like that. And I'll switch to Chrome if like we spend a significant amount of time looking at docs or something. I was in this tab running the test suite to make sure that everything is still passing on master, and I think it is just because I switched to from a branch that has an additional migration that was to fix some compilation errors, and now I am back on master, which does not have that migration. But hopefully just dropping and recreating the database should fix it. I really ought to, in the test suite, just drop the database at compile time. So I was thinking for today, a decent feature to work on would be introducing prepared statement caching. I think we'll just do it for SQLite and see where we are at on time after that. I don't have a specific amount of time that I'm planning on doing this, so I figure we'll just work on that, see how things go, and kind of go from there. So if you're unfamiliar with what prepared statement caching is, when you are performing a query to the database, you need to send that query, and the database needs to parse it and decide what the most optimal way for it to execute that query is, and that's called a query planner. Now, that's not always a super expensive thing, but there is a cost associated with it. So in order to skip that cost, we instead can do what's called a prepared statement. So what that is if you have a query that you know you're going to execute more than once, you send the query over to the database ahead of time with placeholders for all of the values that might change. So for example, if you were building a web app and you had a articles endpoint or an articles show endpoint, then the query you would send isn't select star from articles where ID is 1, you would send select star from articles where ID is question mark. And then later on, you can reuse that same prepared statement, and that will cause the database to not need to go through the query planner again. So we do already use those bind parameters quite literally everywhere in Diesel. We don't even have any code to embed values directly into the SQL. That's sometimes called quoting when you do that. But we don't actually cache the prepared statements. We throw them away every time. So we should be able to introduce it pretty easily for SQLite by itself and not worry about Postgres to start. The cool thing about this is it's entirely sort of an under-the-hood thing that Diesel can do, so we can just have it happen and not actually affect anything. So let's take a look at where we are at to start. So with the exception of this, which is never going to go through prepared statements, because this function is only used for migrations, which we don't want to prepare. Basically, every function that actually executes a SQL query ends up going through this function here, called prepare query. So this takes a Diesel query fragment, which would be anything that comes out of using our query builder DSL. It constructs this query builder struct, and then we walk the AST now in 2 passes. First to construct the SQL, and then create that prepared statement. And then we pass through it a second time to collect the bind parameters and pass those into the prepared statement, and we ultimately return the prepared statement. So this function is what's going to need to change the most. So when you're dealing with an ORM or any sort of abstraction where you want to have a single function that you say, here's some SQL, and go execute it, and use a prepared statement if you can, typically the way that this gets handled, and the way that we handle it in Rails, is we hash the SQL string. And we store the prepared statement identifier as the value and use the SQL string as the key. And that's where I'm going to start here. Now, Diesel has this rather unique case where we have, because of how our query builder is set up, with some exceptions, every single query in Diesel ends up having a unique type. And where I would eventually like to have this go is we actually skip the SQL string construction entirely, because we can just, we'll have to do it at least once to create the prepared statement, but after that, what we can do is at compile time just say, hey, do we already have the SQL string constructed for this unique type? And if the answer is yes, then we just reuse that prepared statement. And what's kind of cool about that is it actually makes our high-level query builder faster than a SQL string literal would be, which is kind of a neat little side effect of our type system. So the first thing that I think we'll need to do, I'm not sure if we need to do anything or if we just need to add tests for it. But right now, we don't ever, so if we go to the SQLite documentation, so we call this SQLite 3 prepare v2, and that gives us back our prepared statement handle. We call various bind functions to set the bind parameters. The functions that you call to execute it are SQLite 3 step, which gives you the next row. Where is it? Gives you the next row or tells you if there was an error or something like that. And then when you're done with it, there are two functions that you can call. You can either call SQLite 3 reset or SQLite 3 finalize. Reset would get rid of the bind parameters and have everything good to go for a second use, and finalize says that you're actually legitimately done with it. And right now, we don't ever call SQLite. It would be SQLite 3 reset. Yeah, we don't ever call it. We do have a drop implementation, and in our drop implementation, we call SQLite 3 finalize. So we do expose this public step function. I'm not even sure that needs to be public, actually. But we have a second function called run. Yes, that does need to be public. That's used elsewhere. We have a second function called run, which just loops through it until it's done, and that's used for cases where the result when we're doing something like an insert statement or an update statement, which wouldn't have a return value. That step function gets called by a separate thing called the statement iterator, which is an iterator over the statement. So we'll need to call SQLite 3 reset somewhere. In my head, I was actually thinking we just need to call it in run, but run doesn't get used when we're actually returning a value. It could be in the drop implementation for statement iterator, but that feels really funky. Let's look at the connection. This is the highest level. This is the public interface, sort of. So prepare query is going to get called from query all execute return count, which, why is that even still there? Oh, okay, that calls run, right? Okay, this is for cases where we're calling execute and not get result or get results, and you actually can't call get result or get results with SQLite because they rely on the use of the returning keyword in the SQL, and SQLite does not support that. I'm sorry if the camera, by the way, is like... Oh, and I've still got Chrome up. Sorry if the camera's switching lighting. There's a massive blizzard outside, and so the glare from the backyard is really, really bad. But there's nothing I can do about it. So there's two places that we could handle the call to reset. We could handle it in run and then in statement iterator. We could handle it in execute returning count and then query all. We could also maybe have this prepare query return some other little wrapper struct that resets it. I think to start, what we can do is I think to start, we'll just have this case not cache the prepared statement at all, because it's just not that important for insert and update statements. And then we'll just handle it here. So we'll do something like this, and then something like that. And maybe we'll even put a try here. No, we always need to reset it if we manage to successfully get a statement. So we don't want to have anything that could do an early return here. Yeah, I think we'll be doing something like this. So statement iterator right now, I think, takes ownership over the statement. Yeah. And the statement requires a mutable reference. So does bind. Okay, that should be fine. So let's just change statement iterator here to have a lifetime of A. This will be there, so we use it, and then, or actually we don't need to use it there. And then we'll take a, is that how you do a lifetime with a mutable reference? I think so. And then statement's going to need a reset function. And sure, let's just require exclusive access. And we will just do nothing for now, because I just want to make sure that this compiles. This is actually going to end up getting a bit trickier, because we're going to end up wanting to have a lot of mutable references to that statement. We'll also end up needing a mutable reference to the hash map that we're using for the cache. But all this is going to want to cross function boundaries, so we'll probably end up having some really funky signature like ref cell, or maybe even just cell, hash map, string, rc ref cell statement. Ideally, I'd like to just not use refcell at all, because I can sort of guarantee, since the statement's never exposed from the connection and the connection can't be shared, I can pretty much guarantee that any mutable reference to the statement is in fact unique, because you can't actually, you couldn't concurrently share a reference to a connection, because it doesn't implement sync. But we'll just end up using RC ref cell for now, and if for some reason it turns out that the reference counting is a bottleneck, then we can deal with it. Okay, so statement iterator needs to take a mutable reference, and then we don't need to call and then. We just need to call collect. And chat has so far been empty. I don't know. I'm pretty sure I've got the right thing open. If you are trying to say something and I'm not responding, shoot me a tweet, and I will make sure that I get that fixed. I would love a confirmation that the audio is okay from somebody. Can I borrow mutable local variable? Is mutable? Oh, needs to be mutable binding, and hopefully I won't get any issues with those lifetimes conflicting. Thank you, Perceptes. I'm not actually going to run the full test suite because we haven't actually changed any behavior. I just wanted to make sure that that compiles. Okay. So let's take a look at some Rust docs, because one of the things that's important to note is that in prepare query, we take a shared reference to self, not a unique reference to self. Now, there's definitely an argument for all of the various methods on connection just taking a shared reference to self, or a mutable reference to self, / unique reference to self, but I haven't poked it as hard as I could. I might explore that a little bit further at some point in the future. But generally speaking, since they don't implement sync, and the only things that that get mutated by it are entirely internal facing. Right now, the thing that they mutate is if you call transaction, we keep track of our depth so that we know whether we need to call begin/commit versus use save points, and then the prepared statement cache will also go in there. So because for now we don't have a mutable reference to self, we'll need to wrap our hash map in something something that lets us cheat. So it's going to probably be ref cell, I think, because regular cell, well, okay, only works with copy data, so that definitely won't work. Yeah, so I'm pretty sure ref cell is what we need here, because we just call borrow mute, we get back our reference. So we'll need to mutate both the hash map and then the values inside of the hash map. And yeah, we're gonna need to wrap the statements in a ref cell as well, because if we just called get mute here, the lifetime of this borrow will or of this borrow, because we're gonna return. I guess for now we'll always return a mutable reference to the statement from prepare query here. We're eventually going to need to have this return an enum that is either a mutable reference or an own statement, because there are certain queries that are not safe to cache, but we're going to ignore that for now. Anyway, so we couldn't just call get mute here because the lifetime of this will be the lifetime of the mutable borrow of the hash map, which will not outlive the function. So we'll actually not return a mutable reference. We will return a ref cell, and maybe even an RC ref cell. Okay, so let's just try poking it and see what works. Key is going to be a string for now because we're just going to use the SQL string to hash, or to, yeah, as the key. And then let's actually just try. I know this is not going to work, but just so we can get everything else around it set up. And why do I? Oh, I have too many. So let's see here. We're going to need to use, oh, and I still have Chrome up, don't I? Maybe I should. I just didn't want to accidentally put my my email up on stream or something, so I've got it limited to only a handful of windows, but I need to remember to switch the stream whenever I switch between these. Okay, and ref cell lives in the cell module, so we'll need to use ref cell here, and then we will need to use If you're not familiar with ref cell, because it's not a thing that you generally need in normal code, it basically just replaces the compile time borrow check with a runtime borrow check. So it's one of those things that you do when you're doing something like this, where you need to return mutable references to things that you shouldn't be allowed to return mutable references to, but you super duper promise that it's not going to break anything. But it will still panic if the aliasing rules get broken. It doesn't remove the guarantees of the borrow checker. It will panic if they get violated at runtime, which is, bad, but significantly better than a seg fault. So I guess what we'll do here is we're still going to need to create this. We're going to need these two lines. And then this line may or may not get called. So let's move that to another function. And I don't think that needs to be mutable now. And the function here would be we're going to return it is still going to be a query result because we'll be calling prepare inside of this function if it is not already in the cache. And let's just say it's going to be a mutable reference to a statement, even though we know that is not actually true. So that would become there. And so let's just, for now, let's not even worry about the cache. Let's just assume that the hash map is in fact empty. So we can call insert. So it'd be something like self.state and cache. The key would be the SQL. That's there. And the value is the result, which I'm going to stop calling result, start calling statement. And this needs to be a string, not a stir. And we're actually probably, I'm just thinking here like, well, insert's going to take ownership of that, of that string, so we're not going to be able to use it here. So we're going to need the entry API, actually. So I guess we are going to be caching either way. So an entry on hash map or insert. Okay. And that returns a mutable reference. So it's... The entry function takes ownership of the key. And this isn't going to fail to compile, first of all, because this is a ref cell. And ref cell has the, I think it's borrow mute is the name of the function. Yeah. And it's going to fail to compile because it's going to complain about the lifetime of that return value, because it does not, it's going to infer that it's the lifetime of self, and it's not the lifetime of self, it's the lifetime of that local cache variable. But I'd still like to see it fail to compile, because if I'm completely misunderstanding how lifetimes work, then hey, job just got a lot easier. Chris, what did you want me to elaborate on? Sorry, there's a little bit of delay with the chat and the stream round tripping, and then I've also got it open on a different computer, so I need to look over there. Oh, why does it need to be a string versus a stir there? Well, okay, so I guess there were a couple of things. So the reason it needs to be a string and not a stir to this function is because the hash map needs to use an owned value as its key, and so that's going to be a string here. And then when you call insert, the signature of insert is owned key, owned value, because it's going to be inserting those into the hash map. So on the line after, if we want to reuse the string to then go get something from that same index, we would need to copy the key, which, given that this is a SQL string of arbitrary length, actually might be, not super expensive, but certainly a non-trivial operation. And so that's the entry API in Rust exists quite literally for this exact case. Okay, we're still missing. No, I just did that. Did I just not run the tests? All right, so that is exactly what... Is that exactly what we expected? I actually can't quite tell from this error message if it is complaining because we are trying to return a value that is tied to the lifetime of cache here. So let's do this. Let's actually do that, and then return unimplemented, which should cause this to successfully compile if that error message is for the reason that I was expecting it to be. Because we're like 3 levels of cheating the mutability rules in. And again, the reason for... let's just do that. The reason that we're having to jump through these hoops is because right now I don't want these functions on connection to require a mutable reference to self. If those functions required a mutable reference to self, then the lifetime of all of the borrows would be the lifetime of self, and we wouldn't have any of these problems. But because I don't want to require that, I might change that in the future, and that would simplify this code significantly. But right now, it will take less work. I'm not even sure that taking a mutable reference to self here is a good idea. I think it might be painful for users. And aside from all of that, for right now, I think it will be less work for us to just cheat the mutability rules than to make the changes that would be required for these methods to take a mutable reference to self. So it's fine, but we'll just end up with those sort of scary-looking type signatures where there's ref cells within ref cells within ref cells. Okay, so let's still just get to the point where it successfully compiles. Whoops. I usually, when I'm developing library code, prefer to work with deny warnings on, even if it means sometimes I have to stop and recompile for semi-pedantic reasons. Compile times also aren't usually quite this slow, but I have a feeling that the video encoding's adding up there. Okay, cool. So why doesn't entry need to be mutable there? As an owned entry. Oh, because or insert takes ownership of self. Okay, that makes sense. Yeah. So this is exact. So it is failing for the reasons that I was saying that it wanted to be, because the inferred signature here is this, but what the lifetime of what we're returning is actually tied to the lifetime of this cache variable, and that cache variable doesn't survive long enough for this function to return. So effectively, that means that the lifetime is this, and because it's not actually static, we can't do that. So what we need to do is return something that is owned. And something that is owned is basically going to be a shared pointer. So a shared pointer would be something like RC, but RC does not give you mutable access. So inside of that RC, we will need a ref cell. Again, in this case, we should know that there is only going to be, well, we actually are even saying we know there, because everything on statement requires a unique reference. We're basically saying that we know that there's only going to be one thing accessing this at a time, but we can't prove that in the type system. At least not without inlining a bunch of functions that I don't want to have to inline. So, it's fine. We'll end up doing this. So it's just going to be entry or insert statement dot clone, and then the return type of this is now an RC ref cell statement. And so the return type of this is also RC ref cell statement. And here we just need to call borrow mute, I believe. Let me just see if that compiles, and then we can combine those into a local variable. And we'll need to import RC, which I believe is from RC. Basically, refcell there is returning that borrow mute function isn't returning a mutable reference. It's returning a little wrapper struct that has a drop implementation to tell refcell, hey, you're free to give something else a mutable reference now. But it implements deref mute, so we just need to put the ampersand mute in front of it to get the deref coercion to work. And here, this just needs to be does run require mute? Run does not, so this can just be borrow. Oh, and then that bind function. Oh, and then the last thing we need to do is in this or insert, this needs to be an RC new, ref cell new statement. And I got the right number of parentheses, yay. I'm very bad at noticing balanced. I don't know what the generic term that would refer to parentheses and square brackets and angle brackets is, but those. And if this compiles, I am actually going to let it run the test suite because I want to make sure we didn't break anything. Make that mutable. And then this might be something we can clean up. But for now, I'm just going to tie it. It's complaining because we can't return result here. Or more specifically, we can't put it in this OK because we're borrowing it mutably here. Or because we're borrowing it just in general. So I'm just going to make sure that the lifetime of that expires. We could also just do this. But that will actually maybe get optimized away by the compiler. I'm not sure. I'm just going to go ahead and do that there. We'll leave it for now. If we decide that we would prefer to move that borrow mute into the loop, I mean, I guess I can just look at the benchmarks and or take a look at the compiled assembly to make sure that gets properly optimized away. Oh, right. Doesn't need to be mutable because the whole point of refcell is giving you a mutable reference without actually requiring mutability. And we'll go ahead and add a super caring about the internals test here. And then we won't really do much testing of this feature outside of a unit test. Database is locked. Oh, right, because we're not reset. No, we are resetting. No, we are not. We're not resetting the... We're not resetting the actual, we're not resetting the actual, who's a what's-its, the actual paired statement objects, and then additionally in the drop implementation for the underlying connection, we need to make sure that the statements have all been dropped before we call this close. So that's pretty easy, or is it? Because drop is going to want to take ownership. Oh, you know what I can do here? Actually, this is really easy to solve. We just need to put that there because Rust ends up dropping each of the fields in sequence, and that's part of why that raw connection is wrapped in another struct instead of me just having that raw pointer on connection directly, specifically so that I have control over the order in which things can get dropped. And that results in that. The reason that was resulting in a in that specific form of failure is because we run migrations in the build script for integration tests. And we compiled, so that's good. I guess we compiled before. Library routine called out of sequence. Actually, so that's statement 121. So I think that's the drop implementation. No, it's in step. Meaning that probably meaning that we need to just call reset here. We'll get a full backtrace if that's not the case. Although there's only one place that step is called, so. That's strange though. It shouldn't be reusing a. Actually in. Oh yeah, okay. So that's this is one of my favorite things about working with compiler extensions is that if you do panic from inside of a compiler extension, it actually says that that you should open a bug report on Rust, even though it's Diesel code gen that panicked there. And the reason that that this occurred is because Diesel code gen does use Diesel internally, and so it would have generated a query that gets reused. And this ensure SQLite OK function just takes all of the various functions from SQLite because it's a C library, return an error code or the constant SQLite OK, and so it basically just turns that into a result of unit or a database error, and grabs the error message if it is an error. And that library routine called out of sequence is basically because we called step after after it had already finished giving the results. And because we didn't call reset, it's basically when the query gets executed the first time, like there's no function that you actually call in SQLite to say, and now go run the query. It's just the first time you ask for a row. And so step won't execute the query a second time until you've called reset at least once. And so if you call step after you're past the end of the query, it will it'll complain that you called out of sequence. So now I've got everything failing. More library routine called out of sequence. Okay, let's do this to make sure we haven't messed anything else up. Let's remove that cache. So we'll just end up returning, okay, well, just end up returning that for now. And then I am now, because I don't want to go fix the unused fields error that I'm about to get, or warning, I am going to comment out that deny warnings, which I will probably forget to uncomment, and will accidentally commit, but that's why we do code reviews. And this sort of stack trace that we got here, this is one of the problems with monadic error handling in general that I don't know a great solution to. Because the stack trace, like the line where it's saying the error is the source line of the unwrap function on result. And the stack trace here is the stack trace of where we called unwrap, but there's nothing here that indicates where the error actually came from. Other than, I mean, it's no different than if you're in like Ruby or something, and you have a no method error, undefined method, whatever for nil. It's sort of the same problem, right? That line's going to be not where the nil came from. It's going to be several lines below. And so just the error handling in Rust and Go and Haskell sort of put you into that same boat, but for all types of errors, which is a thing that is not easy to fix. Especially because like generating a stack trace to include it in the error, especially if you ever expect, if it's an error that you expect to be handled, you wouldn't necessarily want to put the stack trace in the error struct itself, because you can generate the stack trace. There's libraries to do that, but that's an expensive operation. It's part of why you never want to use exceptions for control flow in languages that have exceptions, because when you call raise in Ruby, or throw in Java, that has to construct the stack trace even if you're never actually using it. Okay, so when we remove the cache, it passes. So it's not anything to do with the call to reset. So let's pick an arbitrary one of these. Oh, it's failing in connection without transaction. Begin test transaction.wrap. And begin test transaction comes from... Oh, because it's going to call execute returning count, I think. Well, let's double check this. I'm assuming that it's this function because that's the only unwrap in that method that's failing in. So begin transaction calls execute, and execute calls batch execute. So that should not be using the prepared statement cache at all. Library routine called out of sequence. All right, let's try this to see if this gives us any more information. One of the things that we're working on right now is also improving logging capabilities to make it a little bit easier to debug some of this stuff. Won't always help in cases like, it actually probably wouldn't help that much in this specific case, but you know, when queries are doing the wrong thing, it's helpful to see the exact query that was executed easily. We have some helper functions. We have a macro actually that just takes a diesel query and turns it into the string that would have been executed, but like having to go in there, if you don't know which query is the one that's failing, that's less helpful than if it was just logging everything universally. It'll probably be one of the bigger features in the next release, that and associations. If I finish associations in time. Okay, interesting. So it's not the call to begin that's failing. Oh, I'm reading the stack trace the wrong way. Yeah, it's when it tries to insert. Oh, of course, we're not calling reset from run is the problem. I kind of want to add a specific unit test for this. And this test is gonna, because we never exposed the statement object through public API, so this test is either gonna reach into the internals of the connection to get the raw connection, or it's gonna reach into the internals to call that prepare query function. And I feel slightly better about reaching into it here. So this should fail because we haven't called reset from that run function. Those are always the worst when it's like after it took more than 2 seconds to compile, it's like, oh, and I need to add an ampersand and now wait however long again so that the ampersand satisfies it. I mean, I'm definitely not complaining that we have references. Those are a good thing, but it's always just like, ah. Okay, I'm not even gonna worry about why those are probably failing because of other issues right now. What's more a problem is that this test should have failed. Yeah, it should have failed because I'm pretty sure the library the error message they were getting from the integration test is because we are not calling reset in our called run. And the reason that I'm assuming that is because it was coming from the functions in our test suite that are responsible for inserting data, and so that ultimately would have called execute returning count and not execute, or not query all rather. And we've already confirmed that execute is not the function that's failing. And query all is definitely calling reset. So I believe the issue is that it is calling SQLite step. You know what? Actually, that is a good point. We should make sure that we should verify that this is in fact the function that's failing. I'm thinking maybe perhaps the reason that that test was passing even though I expected it to fail is because the test didn't have side effects, or the query didn't have side effects rather. I really need to go through this. The test suite doesn't normally, like, the tests that I run all the time usually don't have this many errors, or warnings rather. But when I added SQLite support and I started making our test suite backend agnostic, I didn't. There's just a ton of like small things that I didn't put the CFG flag on because I don't want to have it on every friggin' use and function. Huh, okay, so it's not coming from run. Well, the only unwrap call is here. Right, and we're positive that the unwrap call is occurring. No, I'm reading it back. I was reading it the correct way in the first place. So this is the lowest. Is it the migrations that are failing? So it's definitely not this. Pretty sure it's not that. What type of query error, database error? Query error is... It is the migrations that are failing. Interesting. Which means... Which means, because batch execute definitely can't be failing from this. So that means that it is failing when we try to set up the database and or keep track of which migrations have been run. Actually, you know what I'm going to do here? I'm going to demonstrate to everybody how terrible I am at debugging. I'm just going to put in... I'm going to print line debug here. Well, that should still mean... That should still mean that run was the thing that was failing. Maybe not. No, I guess it could be the select star from diesel schema migrations. Wherever the hell we call that table. So when you run migrations, we do several things. The first thing is we look to make sure that our metadata tables are set up. Right now, if I recall, we still just have the one table that keeps track of migration versions. But in the future, I'm going to have a secondary metadata table as well. That will store things like, for example, which version of Diesel it's set up for. So that way, if I need to change how our migrations work, I can check that version number, and if that version is different than what I expect, we can basically migrate our migration infrastructure. But right now we just have one table, and it just keeps track of which migrations have been run. So basically, the first thing we do is we run a create table if not exists. Then we go and select all of the migrations that have already been run. We look at the versions of the migrations we're trying to run, remove the ones that have already been run, and then loop through and run each of them. After we run each one of those, we insert a row into our migrations metadata table to track that it has been run. And it is failing when we try to run the actual migrations. We should run several queries, so it's either... Oh, you know what we can do as well? Can do that, so we'll get this output, and then yes, it's migrations all the way down. I've actually been it's funny if you look, so like Diesel CodeGen uses Diesel, and Diesel also uses Diesel. But I can't use Diesel CodeGen from within Diesel or Diesel CodeGen. So I can't do things like that. In the lack of having derived queryable is not that bad, because queryable is a really easy trait to implement yourself. But implementing like insertable into is kind of a pain. I've been wondering if maybe I can use Diesel CodeGen to bootstrap the compilation of Diesel CodeGen. Which would be funny. Because in theory, there's no reason that I couldn't have Diesel Code, the latest released version of Diesel CodeGen, as a dev dependency or build dependency of Diesel CodeGen. Although it might be weird to set that up properly so that it works with syntax when needed. Of course, the actual solution is I need to just make insertable into and change that for more pleasant if you're not willing or not able to use syntax extensions. Okay, so it's failing on inserting new migration, and for whatever reason, this isn't getting written. Okay, that makes sense. It's failing on the second migration. So it is, let's see here. Where is... So it's failing the second time that tries to reuse this. And that should call insert returning count, I thought. Or execute returning count. Right? Because that returns a query result use size. So that must, yeah, it's calling execute returning count, which calls run. But if run's not the thing that's failing, oh, of course, it's failing when it tries to call bind, because you can't call bind, then step, and then bind. You would have to call reset before you can call bind again. And that's why that test was passing, which I should have not deleted, because I just need to put in a bind parameter. Okay. You know what? I'd actually rather just set up the type system in such a way that I don't need this test. So, like, And we'll do something similar to this, which I need to pull into its own function. I'm actually kind of surprised this isn't in the standard library. Because it's like we can't return a result here because we're inside of drop. But we do need to blow up if this fails. But if we are already, like, the most common reason that this would fail, right, so we're inside of drop. And the most common reason that this would fail is if we're inside of drop because something else panicked because we're in an inconsistent state. So we can't just actually always panic here. But we still need to output. We still need to output the error message. So if we're already panicking, we just write the standard error and continue to unwind because we're panicking, so it'll be fine. And if writing standard error fails, we just abort your process. But if you panic while a thread is already panicking, it aborts the entire process, which is bad. To answer the question about whether the SQLite warnings I mentioned earlier, how do I make them go away? In the test suite, I'm assuming is what you're referring to. Yes, some of them go away just because I will implement certain features. Like several of those were in tests, ensuring that date and time types are implemented correctly. And so when I add date and time support to SQLite, those warnings will go away. The other way I would make them go away is just by putting a CFG feature equals SQLite on a bunch of things that I just haven't, because I don't know. I probably should. I feel less inclined to have deny warnings on test suites, though. But definitely for library code, I always keep deny warnings on because, I don't know, I just feel like that's a thing that you should do. This is going to complain that a bunch of stuff is not in scope, but I don't care. I will fix those when it complains. So here, this no longer returns RC ref cell statement. This returns cache statement, and I'm already liking this direction, just because this code is so obviously cleaner. I guess obviously is not a good word to use there, but it feels a lot cleaner to me anyway. Should have done this in the first place because now it's just going to replace the one last occurrence, but whatever. And I didn't balance the angle brackets correctly. That can go away. That can go away. That should be everything. Okay, we need RC ref cell and dref. And the reason I like this is because it means we don't need to remember to call reset. Now it's impossible for us to forget to call reset. And that also means that we can make reset private. This doesn't, like, the mute there is semantically correct. It doesn't need to be because we're not doing anything that requires a mute reference. I'm just wondering if actually, like, how drop behaves with those lifetimes. I'm going to just assume it's fine until it blows up. And And we're implementing deref here to the ref cell because we're using this in place of that RC. And we were relying on that deref implementation earlier in our code, and I didn't want the other code to change other than the type signatures. And we're derefing to ref cell and not RC ref cell so that calling clone returns this cache statement, not an RC. Otherwise, the statement would get reset too early and everything would blow up. What was I thinking? Oh yeah, I need to go delete that call to reset here. That means I can just do this. And then I can do that. And it'll just reset automatically because we'll be done with the statement. Oh, I do still need ref cell here because the hash map is also in a ref cell. And I do need that to be in a ref cell, right? So I'm calling entry. Yeah, entry takes, of course, entry takes me itself. All right, magic moment. I think everything will pass now. This is not Ruby. Polyglot problems. I always forget that I need parentheses in Rust, and then when I go write Ruby, I put let in front of all of my variable bindings. And then yell at myself, this isn't Rust. Huh. Wrong file. So it can no longer figure out the SQL type. And type. Does that fix it? Oh, semicolon. If I actually went and fixed all of those, then it would eventually get to the not all control paths return a value. But it's not getting that far because it can't infer the types because all of the types that it's trying to infer rely on it knowing that the result of that expression is the return type of the function. Should actually open an issue for that because that's an error message that should and probably can be improved. Okay, that's fine. Gonna turn off the backtrace in case it does fail with something that is not absurd. Interesting fact, the bulk of the time that Diesel spends in its compilation is just figuring out tuple implementations for various traits. And that's why by default Diesel only supports tables with 16 or fewer columns, because the compile time of Diesel itself goes up factorially with the number of tuple implementations that I have to write, and one of those is, well, a few of those are the implementation of SQL type. So the implementation that says, given a tuple of these things and all of these things are SQL types, treat the tuple of those as SQL types. And then also things like expression. So, because select takes a tuple when you want to select more than one column. So it's the thing that says, given a tuple of all of these expressions of these various types, then a tuple of those expressions is an expression of a tuple of those types. And so we just have a bunch of those, and those are required for your table's default value for its select clause, and among tons of other things, but that's specifically why it's affected by the why the max table size affects it. So that's why the implementations that add support for up to 26 columns and then up to 52 columns are both hidden behind independent feature flags. And I'll probably up it to 104 when somebody complains that 52 is not enough. Although, I mean, at some point I'm going to draw the line and say stop, just pull that into a separate table. But I don't know if 52 is that line. Okay, why did we fail? Bind column or index out of range? Am I thinking that I had already done a refactoring that I haven't? Does the statement keep track? Yes, the statement still keeps track of its bind index. This is a thing that I had intended to move to a different struct, but I have not done that refactoring yet. So in the meantime, right, that's the default value, I think. Yes. My plan is to, I'm refactoring how SQLite handles bind parameters in general, because the way it works right now is a giant hack to make it so I didn't have to change the way our toSQL trait works to add SQLite support, but it's a humongous hack, and I need to fix it. And as part of that, the bind collector is what I call the struct responsible for walking the AST and gathering up all the bind parameters. I'm going to move tracking the bind index to that struct. And in my head, I thought I'd already done that, but I have not. Another fun fact about the tuple implementations, the reason that the cutoff, the 16 is just an arbitrary number that I picked, but the reason that the large tables feature goes up to 26 and not, say, 32 is because the macro invocation that I call uses letters for all the type names, and I have a little editor macro that I use that copies the tuple implementation and then just increments everything. And so one of the basically all of those type variables needed to increase by one letter, and I didn't want to write that in my editor macro. So when somebody was like, I have a thing that's like 20 something columns, I picked 26 because that is the number of letters in the alphabet. Okay, cool. So our tests are passing, other than that I have that print standard out, which I need to replace. Is that all that changed here? Yes. If you haven't seen this embed migrations thing, this is a new feature that'll come in the next release. It at compile time goes and reads your migration files and then puts them in a module so you can call them later at runtime. Really, really important if you are doing any sort of embedded use case or just don't want to have to deploy to your server with also the migration files. Yeah. Okay, so I'm going to now run the full test suite, the semi-full test suite. We've got a little script that's just a bash script that I can give it arguments to run smaller subsets of the test suite, but it basically goes and runs the test suite for every one of our crates for Postgres when applicable, and then for SQLite when applicable. But it only runs the nightly test. It doesn't run the stable tests. So Travis handles the stable tests. So this isn't done, even though it seems like we might be done. There's a couple things I want to do. I want to add a unit test to the connection that says it does in fact cache prepared statements. And then the other thing that we're going to need to do is there are prepared statements that are not safe to cache. I mean, not safe is the wrong word. So one of the things that you may notice is that we are just sticking the prepared statements in a hash map, and not something like an LRU cache. And so that means that they are tied to the lifetime of the connection, but that's just because it has to be. But basically, there is, in theory, unbounded growth of that prepared statement cache based on the number of queries that you run. Now, in practice, you're not running an infinite number of queries. You're running a fixed number of queries, and the number that would have to be, it would need to be absurdly huge for that to actually bust the cache. But there's two cases where, even though query looks like it's the same, it's not something we would want to cache. The first one is if the query contains an in clause, because SQLite doesn't have an array type. Each individual element of the array needs to have a separate bind parameter. So that would generate one prepared statement per call to that query based on the length of the value to that in clause. And so that can grow very quickly. The second one is if there's a SQL literal node in there. And there's arguments for or against not caching ASTs that contain a SQL literal node. But basically, because it's fine if you're just using the SQL literal node for some constant SQL that you're only doing because you need like group by support or something. We haven't added that yet. But there's no way I can really know whether you are dynamically generating some part of that. And I don't want to expose APIs that make you care about the internals of how we're performing prepared statement caching. So I would prefer to just not cache ASTs that contain a SQL literal node. So once this test suite finishes running, what we'll do is we'll add that first unit test, just to make sure that we are caching in the first place. I'm also gonna, before we even do that, I'm gonna run benchmarks with and without this to see if there shouldn't be a huge change, especially because I don't have any queries in the benchmark that would spend an enormous amount of time in the query planner. But I want to make sure more specifically that we haven't caused any performance regressions is more what I'm looking for. And then we'll add that unit test to make sure that we are caching. Then we'll write the second unit test to make sure that we are not caching queries that shouldn't be cached, which will fail, and we'll add that additional AST pass to test whether it should be I need to add allow dead code and everything else to that macros output. But that is not related. Yeah, so then we'll add that additional AST pass to check whether a statement is safe to prepare. Some other places that historically have made queries unsafe to prepare but don't affect diesel would be things like limit or offset. Many ORMs, including Rails prior to version 5, or Active Record rather, will just embed the limit or offset directly in the query because it's really, really easy to do. And there might be backends actually somewhere that don't support bind parameters in those positions. I think MySQL used to not support bind parameters there, but nowadays every backend that Active Record supports and that Diesel supports definitely support using bind parameters there, and Diesel's always used bind parameters for that. Yeah, basically any part of the query where the SQL would change without the type of the query changing basically is something that we need to make sure does not go into the cache. There's also an argument for this should be an LRU. I'm going to probably I'm gonna poke it and see if I feel like it's worth, because that has overhead, and part of the goal of this is to completely eliminate the cost of the query builder. So if we're having to do usage lookup stuff every time we access the cache, that's a problem. And my gut is telling me that if we avoid the cases that are known to cause expansion of the query cache size, then it will be fine that even if it is technically unbounded. Anyway, I'm going to go use the restroom, grab some water, so I'll be back in 5 minutes, and then we'll finish up this feature. All right. So the tests all passed. So I'm going to commit before we do anything else. I'm going to double check that deny warnings, that there isn't anything that being commented out was failing to catch. And if there was a warning, it would have failed to compile by then. Okay. Benchmarks. That's the next thing. So what's really cool about the second half of what we're going to do is, so we're not going to, if this were Rails, for example, and I was adding something like, actually I did add something very similar to this to ARail in Rails 5. Basically, we need to make sure that everything we're trying to do, we do in a single pass over the AST, because walking the AST is very expensive. And so what I do in Rails is, I don't remember if it's a module or a class, but we basically create another visitor that tracks whether something is safe to be prepared, and then every time we're gonna do it, we wrap the original AST visitor with this new one, so that way we only have to walk over the AST once. But like, everything sort of has to know, or this thing has to sort of know everything about when and how the other visitors are doing it, and the place where we decide, and now we're gonna wrap it with this track if the thing is preparable visitor, is very non-local from where it matters. That's not a problem in Rust, because our code gets optimized and inlined and monomorphized. So we're gonna do this as a naive additional pass over the AST. Right now we already walk the AST twice, and interestingly, changing Diesel from walking over the AST once to walking over it twice actually was a performance benefit. I was checking for regressions, and it turned out to be like a 5% bump in some cases. And I'm assuming that's because the optimizer was better able to deal with some of the string construction stuff. So it's going to be, for example, we have a binary node called AND, which has left and right. And so AND is safe to prepare if the left side is safe to prepare and the right side is safe to prepare. And that code's going to end up getting monomorphized, right? So let's say the left side is a column, and the right side is, or the left side is like, I don't know, column equals foo, and then the right side is column in bar. Foo and bar being just things, right? Foo, I mean, foo would be any expression, and then bar would be some sort of array. So that code will end up looking like so the code for equals will be the same as the code for AND. It's safe to prepare if the left side is safe to prepare and the right side is safe to prepare. And in this case, both the left side and the right side would be. And then the code for in will be false. So once that code gets monomorphized and then inlined, that'll end up being a function that just looks like true and true and true and false. I might have one too many trues there. Anyway, right, and then the optimizer can look, okay, this expression is the same as just false, and so it will just get replaced with false. There's a little bit more of a cost with the let me fix this really fast so I can run these while I'm talking. Now I've forgotten what I was about to say. Oh yeah, boxed queries. Because those are going through trade objects, there's a little bit more of a cost there. But depending on when and how the query got boxed, the majority of that query still would have ended up getting boxed. So it's or would have still ended up getting inlined because the fact that it's going to dynamic dispatch doesn't mean that like every single part of the AST switches to dynamic dispatch. The compiler can still inline. So if it's, for example, if it's and both the left side and the right side are both boxed, so and is now no longer going to be inlineable or optimizable, but that EQ that's on the left side, that can still get optimized. So in that case, it would still compile down to true and true, or if it's a larger AST, it'll still get optimized to a literal. And so and then ends up being dynamically go look up the answer to this, and dynamically go look up the answer to this other thing, which is still very cheap. And in practice, you usually won't see the AST get segmented too much by boxing. Okay, so that's what this looks like with the feature. Now master. We may have introduced a regression. Those numbers look larger than they should. Although, no, you know what? It's probably just slower because my CPU is running on video encoding as well. In fact, maybe this isn't the best time to be benchmarking, because I have a feeling that the video encoding is not a constant CPU, predictable CPU usage. We'll see. If the numbers are the same, then I'll treat that. I'll definitely run these again once I'm done streaming to make sure. But anyway, so the point about all of that with AST walking is just I think it's really cool that we can implement, because we're using Rust, and Rust works really, really well with generic code and optimizers. We can write this code in a super naive way, and it will basically just compile down to a literal. Is this where I podcast from? Do you mean like my physical location? Because yes, my physical location is my house, and this is the only. I work remotely right now because I do open source full time. I'm actually moving to Canada in a little under 2 weeks, and then I'll have an actual office and soundproof room and everything. But for now, yes, this is where I podcast from because this is where I am 100% of the time that I'm not at a conference, which is not terribly often. Second question: any activity on the web framework for Rust, which usually I just refer to as YOF, the web framework, because Diesel before I named it was YAQB. I'm consistent in my code naming schemes. No, I haven't had a ton of time to work on it lately. I've been at conferences, and Rails 5 has taken up the vast majority of my time. But I'm hoping to maybe not like something ready to go, but I'm hoping to have the API at the point where everything's up and people can look at it and comment and contribute. I'm hoping to be at that point maybe next month, but we'll see how it. I'm at 3 conferences, so we'll see. Yes, one of the best things about the thing that sucks now that my visa's finally come through, because I've been waiting for my visa for almost 6 months, is that now I can no longer be like, if X wins, I'm moving to Canada, which it's always fun. My employer is Shopify. They pay me to work on Rails full time. Okay. So it is within the standard deviation, but the fact that the standard deviation goes down is a good sign as well. I will still need to rerun this when I don't have video encoding running, and because our standard deviation is so high, I need to run it a couple dozen times to really get a good feel for these results. But at first glance, we're seeing a decent sized performance improvement. In both cases, it looks like it's about 1 to 2 milliseconds when it's selecting 10K rows. So that's too large. This should not have that big of an impact. But there might also be something about SQLite's behavior in this case that I'm not aware of. But this is good, and definitely doesn't look like any regressions have been caused. So that's good. I am going to commit this change to the benchmark script on master. Tamarja, I'm not sure I understand the question. What the hell branch was I on? I have a branch where I worked on a similar feature and did not finish. The performance work? No, I mean, this is just a thing I've been needing to do for Diesel, and I don't know. I kind of wanted to try out streaming this morning, and this seemed like a feature that I roughly knew how to implement and just needed to do that, and like constraint small enough that it would be something we could bust out in the morning. Okay, so next, unit tests. So let's see here. actually, no, we don't need. I was thinking like we were gonna set up a table here, but we don't need to do that. I just need to avoid using a SQL literal node, but that's fine. Although this is actually going to look kind of ugly. Actually, I can just do this, I think. Make sure the query runs, and then assert that the statement cache has a single entry. Yep, the double colons can be fun. I'll show the thing that I was like groaning about that I don't think I need to do, but would have been painful if I had to. I'll show that once this finishes compiling. Oh, right, because that needs to know. The actual type of the expression. So the thing I was thinking I was gonna have to do. So we have this trait called as expression, and another trait called expression. Expression represents things that go inside of our AST. Combination of, well, specifically a combination of expression, which is used for type checking and all of that safety, and then query fragment, which is used for the SQL construction and making sure that things are compatible with the correct backend. So we have a trait called as expression, which is a thing that can be converted to an expression of a given type, and that's why you can pass literal values to methods like EQ, because we just have that as expression bound everywhere. The problem is when it can't infer the correct SQL type, because of the way the trait is defined, as expression is generic over, because we don't have higher kind of types, as expression is generic over the trait is generic over the SQL type that we're converting it to, not the method. So if I needed to specify it like this, I couldn't write it like this. I would instead have to do and actually it doesn't take a reference. But yeah, I'd have to do something like that, which is just like, I mean, it is the fact that this, I do think it is good that it is done this way, because the amount of complexity it would add to the language for the form that I showed before, even though it's prettier, the amount of complexity this would add to the language isn't something that we want if we want the compiler to generally be free of bugs, because complex features tend to be more bug prone because open source maintainers aren't magic. Let me remember to import the other thing I need. I don't need these double colons. But yeah, it's just unfortunately painful when I need to specify the type. What you can do to work around it is just have two traits. One that's generic over the one that's like the actual implementation and is generic over that type parameter, and then another one that Well, here I can show you because we do this for the reason I haven't done this for as expression is because as expression isn't something users interact with, but the boxed DSL is. So this is the actual trait that determines what the into boxed method does. But it needs to be generic over the back end because to box it up, we need to know what connection you're eventually going to use it with. But if you're in a case where the compiler can't infer the type for DB here, I don't want you to have to write that really painful long form way. So then we have the public one, which just has this single method that takes A and DB, or that takes the lifetime and the parameter, and then just has the constraint where self implements the trait for that specific backend. And so this is the method that you end up calling. And so that way, if you need to specify it, like up here in our example, if you need to specify it, would just be like that. So that's a nice thing. And then we just implement it for all t, which is fine because we quote unquote monkey patching in Rust is completely safe because the traits that add those methods need to be in scope. And if there's ever a conflict, it will explicitly tell you that there's a conflict and you should disambiguate. Is there a good web framework for Rust that I like and or recommend? No, I'm working on a web framework because I don't like the ones that are out there right now. Iron's probably the best option for the time being, though. Yeah, that's actually the main place that I'm sort of hung up on right now with Yoff is trying to figure out the right API for when you have code that basically is per request that you want to deduplicate. I am separating that out from middleware because I think middleware should be specifically tied to HTTP, stuff like gzipping and that sort of thing. Which is exempt from this problem. But yeah, I really don't like the type map that Conduit and Iron use there because it just completely throws away type safety. So I'm trying to come up with something that is still composable, but actually it is type safe and it gives you the exact types and you know that they are there, and not what the type map stuff has to do. Yes, I am eagerly waiting on incremental compilation. It will help Diesel's compile times enormously. Although a lot of where sorry, one sec. A lot of basically all of Diesel's slow compilation stuff just comes from the amount of traits that we implement. And there are other optimizations that I actually haven't explored it enough to be able to say whether this is actually possible. I'm pretty sure there are some major optimizations that can be done in trait fulfillment lookup that would not walk every trait implemented ever, or every type that trait is implemented for ever, and would speed our compile times significantly. But yeah, I mean, incremental compilation is going to be huge. So I'm going to see if this actually does just need to be disambiguated. And I can eliminate this. Again, right? Like, normally you're not. You have something that is already an expression, which is your starting point. Normally, when you work with Diesel, you're dealing with column, some operator, and then some value, or even and. Like as soon as you are beyond the first method call in the chain, you never have to care about as expression. But in this case where I'm trying to write select one without using the SQL literal select one, it's One of the things to keep in mind if with regards to YAF versus Iron is just YAF's also going to be targeting a very different category of web apps. It's going to be a much more, I don't know if heavyweight is the right term to use, but opinionated, I guess, much more opinionated. All right, hold on. I'm gonna make sure. I want to see this test fail at least once, so I'm going to. So there's a lot of questions for me to answer, so I'm just going to put this. I'm gonna remove the caching. What? There we go. And then I will answer some of these questions. Okay. How has my experience in a functional language like Scala helped me learn a language like Rust? A lot, because the type systems for Rust and Scala are actually quite similar. I question how much of the complexities of the type system actually need to be known for like the average Rust developer. It's definitely a thing that I care a lot about with the generic code that I have to write for Diesel. But the average user is just not going to write code that is this generic, which is why our type signatures sometimes look much scarier than normal code would. I think Rust definitely has a much more elegant design than Scala, but I would say that my time with Scala definitely just gave me a good knowledge base coming in. A lot of the concepts are very similar. Ultimately, Rust's type system is closest to Haskell. So I would say my time with Haskell is probably at least as useful as my time with Scala when it comes to learning Rust. But I'm not necessarily sure that it would be as beneficial to the average Rust developer who's just not going to be writing super generic code. So on the Hello World benchmark, one of the things that I hate about the web world right now is that we are getting way too hung up on Hello World benchmarks lately. I'm not saying that that isn't indicating a problem, but it is very possible that Iron is slower in Hello World, but that turns out to not scale with the amount of work that you're doing with Iron, and turns out to be trivial in a real application. I have not spent a ton of time with Iron. I couldn't tell you whether it is actually significantly slower in real world use cases, but I would be wary of using putting too much weight on a Hello World benchmark. Any suggestions for somebody with only Ruby background coming to Rust? Yeah, the Rust book is great, and then I also really like learning Rust with entirely too many linked lists, which I'll just link in the chat. Why did it delete my own link? Okay, there we go. I don't know how Twitch works. Oh my god, come on. Just show me the test fail so that I can go back to the code where the test passes. I'm not going to go change the fucking name of that field. But I do think something like Iron is a necessity. I'm not sure if Iron is the best API possible. Again, I haven't spent a ton of time with it. but it is the only one that I've spent some amount of time with that didn't piss me off so much that I immediately abandoned the thing I was working on. But like, there's definitely always going to be space for something akin to Sinatra or Expressed, and that is going to always just be the types of apps that Yoff is targeting are not the types of apps that something like Iron would necessarily be targeting. Okay, cool. So our test does in fact fail. I sometimes feel less of a need to have and I want to see my test fail at least once in Rust because the type system gives so much additional help, I guess. But in this case, all right. So now, not cached when containing. So we'll do the same thing, but instead I'm going to call do I re-export SQL at the root? I don't think I do, but and this should be 0. So that fails. Yeah, no, that's not in the root namespace because I don't expect people to use that because it's not a thing that I recommend unless you are doing something like testing diesel. Also, these are backwards. And I am actually going to put this in a module because I'm about to write a third test as well, and I'm going to have those same imports. Okay, so this is what we want to see, right? This is not a thing that is safe to cache, arguably, but we are still caching it. So, let's see here. I guess it's an RC ref cell. I can always just have this be we're preparing the statement regardless of whether it is in the. How do we even test that? Because this line is a waste right now. Like, I'm gonna run that really fast to see the results of this if it is much. But we're not actually like we're still saving some work, I think. But we're still creating a new prepared statement object even when there's already a cache entry. We need. Go away. We need to be calling or insert with. wait till it says it's done compiling diesel. Well, I guess I can change the file. Crap. Okay. So the problem here is that preparing the statement can fail. But I don't want to stick a result inside of the cache. But that try now is at the wrong level. All right, I'm going to write this, and then we'll figure out how to remove the duplication. I don't think this is going to work. This is why the entry API exists. But okay, you know what this can be? This can be cache.get. We have the same problem there. The result is at the wrong level. And insert just returns option V. Oh, it returns the old value. If there was one. In this case, we know there isn't. And actually, we still need the entry API here. Okay. See if that still compiles. I'm pretty sure we're going to have a conflict between a mutable and immutable borrow, but Tabarja, not safe to cache in any database. And again, I guess safe is not the right word, but would generate more potential, like defeat the purpose of prepared statements, because the number of prepared statements you would have to create for the same query is unbounded. Yeah, so we end up creating an immutable borrow here. And I don't think this gets helped by doing I guess the simple answer actually is just to stick the result in the cache. Is that even bad? Okay, well, if I change the type signature here, so this would become entry or cert with I mean, so the downside here is if it fails to prepare the statement for some reason, then it ends up caching that error, and then you would not be able to try and prepare the same statement again later. But is that even a bad thing? So why could it fail to repair? The SQL's invalid, or the connection's bad, and neither of those are recoverable cases. This is entirely internal, so I could always change my mind on this later, and it wouldn't break anything. So I could probably just do this until there's evidence that this causes an issue. Yeah. How do those benchmarks do anyway? Oh, the benchmarks. I'll fix that in a second. No, the reason the benchmarks failed was because that change that I made to the benchmark file to set the database URL to something isn't there. So it's trying to connect to a Postgres URL, which is not a valid file. Maybe. Rust is not generally painful to use TDD with. Diesel, it has an exceptionally long compile time, and it's made significantly longer because I've got video encoding running. Normally it takes less than half the amount of time it's taking right now. Hold on. What is but no, I don't. The thing is, I very rarely run my tests with the expectation that the tests fail. Normally, I'm actually running it so that I can see the compiler failure, which tends to come pretty early. But Diesel's also just more affected by some performance issues that the Rust compiler has right now than average code would be, just due to our enormous use of traits, especially with tuples of various sizes, but it's something that is on the core team's radar and is high up on the priority list to fix. I'm still just thinking about whether or not I that is a valid point. That is a reason that you might write your code to recover from the statement failing to prepare, but it would succeed later. Yeah, so I will go back to this form. Okay, so I do need to do this, and then I'll just have to throw an unwrap in there, and that's fine. Unless there's a method on hash map, which I don't think there is. Unless it can just be that. But yeah, with Diesel in particular, I do spend more time waiting for the compiler than I'd like. Which is also why I tend to take slightly larger steps than I otherwise would, but I don't know, it's a trade-off, right? Because I'm also not needing to run my tests as often as I would in a non-compiled language. But yeah, when the compile times get to be this long and it's something like that that it fails for, that's always unfortunate. Okay, so what I'm going to do here is rebase onto master, so I get that change so I can run the benchmarks. And then, again, I'm just going to check the where the performance is at. You know what? I can do that later, because this should not have caused any major change. Okay, so let's get that test in there. Okay, so that should be the minimal test that fails, or that test description will lead us to an implementation that will pass but not be done. This is Rust, if that was the question. Okay, so what we're going to do here, right, that was why I realized this was because I also need to now further add duplication to this code. And cache statement now becomes the wrong name for this because we're going to return an instance when this isn't cached, but it'll be fine for now. All right, we're gonna write the really terrible form of this code, and then we'll figure out a good way to do it. So now we're gonna do like something like else if. I'm actually gonna move the construction of the SQL into this function. Because we're going to need the actual query source and not just the SQL. Then this is going to change to else if source is safe to cache prepared. Else, we're going to do the same thing, but not put it into the cache. This is why cache statement now becomes a really awful name. And yes, this method needs to be refactored, but we will come back to it. So we're going to need to add that method to our query fragment trait. And I'm just going to give it a default implementation to start. This is the wrong trait. I will check out AutoStash when I have a chance. I don't know how to pronounce your Mr. Liquid. Yes, Diesel will probably be faster. We tend to be competitive with super hand-rolled C. And we will almost certainly be faster than RU SQLite because its implementation is very similar to Rust Postgres. We perform about 30% faster than Rust Postgres for most queries. So I'd expect similar differences to RU SQLite. A lot of what they do just isn't well suited for the optimizer. So we're getting pretty close to lunchtime. I'm not going to stream fully adding this method to every AST node because it's going to involve me basically just running an editor macro on a bunch of functions and then like manually examining the result. Because the implementations are going to be mundane. I'm going to leave the default implementation there until I get like a handful of things to demonstrate the point implemented, and then I'm going to probably after lunch remove that default implementation, which will cause a compiler error on like every file in Diesel, and I will have to go add a bunch of the implementations, but it's really mundane and straightforward. Okay, so the code compiles and it's failing. That's what we expect. And so what I'm going to do now is I'm just going to only override this for the SQL literal node. Right, and so there will be two things that return literal false there. SQL literal node and in will both return false. I will also probably just end up returning false from insert statement and update statement because changing the signatures of those to handle this would require some additional work, and those just aren't queries that are important to cache. And then everything else will either return literal true. So things like columns will return literal true. Bind parameters will return literal true. And then anything that is a composite node of some kind, be it unary or binary, things like equals, and, or, all of those sorts of things. And then binary things like descending. Is a node. All of those will say that they're safe to prepare if all of the things that they're built out of are safe to prepare. This is the sort of thing where it would actually be really cool if custom derive were easier to do without a macro. Because I could totally just put this into a different trait then, and then just add that derive to like everything, because it's a really trivial derivation. But okay, that's. I would have expected that to pass now. So let me just make sure I do in fact have a SQL literal node. Yes, I do. Oh, select, right. So this is probably one of the scarier structs you'll ever see. This represents an entire select statement, and because diesel is super type safe, every single part of the statement is a unique type, so we end up with these really big where clauses. These ones actually aren't that scary, they're just big. Some of the other ones can look pretty scary. If you tend to follow me on Twitter, then you'll have seen when I killed a function called find, which I didn't actually kill, I just moved it somewhere more sane. But the original where clause for it was obscene. I can actually pull up the commit if people are interested, because it was. I'm fairly certain I have written the scariest where clause anybody has ever written in Rust ever. Right, and so this is what most of the implementations are going to look like. It's going to be like self.distinct.is. Well, I'm going to do it this way. Whoops. Right, so that's roughly what it'll look like, and that process I just went through is what it'll be for most nodes, because I can just put that in an editor macro. So now this will end up returning false, because this will be an instance of no distinct clause, which will return true. Where clause will be an instance of no where clause, which will return true, etc., etc., etc. Select will be our SQL literal, and that returns false. So once this gets monomorphized and inlined, this will compile down to true and false and true and true and true and true and true, which then will get inlined to false, which is why we can do this AST walk for free. But yeah, I'm super excited for this will be cool, and it's good to have, and I'm glad we have it. But what I'm really excited for is to then take it one step further, where for queries that, again, do not contain SQL literal nodes, and aren't boxed. Yeah. Yeah, for queries that don't contain SQL literal nodes and aren't boxed, we will then be able to change the key of that hash to be a type identifier. So that will be a literal at compile time, and we will not have to construct the SQL string at all, and so we will literally be faster than a SQL string. Because we skip that hash. We skip the hashing function entirely. Because I'll be switching that to a B tree map, which, well, I'll benchmark it, but basically, in either case, hashing a U64 is cheaper than hashing a string. So I'm gonna now make this a little bit more general. ASTs containing SQL literal nodes. Containing. Right, so this will then, I mean, I sort of already have that with select, but whatever. Actually, yeah, well, it's fine. So I'll do something like, right, so when we have an EQ node containing a bind param and a SQL literal, that should fail. Or it should not get cached, which means that then we'll have to go to predicates, and this will actually do it for like friggin' everything, not just EQ, but. And I need to clean this up because this does not need to be as generic as it is. This is what I want. Is safe to cache prepared. Oh wait, this is infix, not, or postfix, not infix. Where the heck is? Infix, predicate to SQL. Okay, yes, this is right. Right, and then bind params. I mean, right now they're using the default impl, but or the default implementation of this function, but I may as well just write it because I need to anyway. Right, this one just returns literal true. So then that would pass, and then the last one that we're going to want is ASTs containing in clauses need to not be cached. Oh, and this will need to be true is what that returns. So then I'll change this to be like in vec 1, 2, 3 or something like that. Is that called in? I don't even remember what I called it now. Because in's a keyword. I don't think I can have a function called in. Yeah. Or is it just complaining because I have too many of those? Oh, maybe I can have, maybe I did call it in. More streaming later. Probably not today. I'm gonna head over to my cigar club after this, and I wouldn't be able to stream from there. But this was kind of fun, and so I will probably do this again. I don't know when. But I am going to get this to a point where it'll be roughly finished, and then I'll just need to go basically finish implementing this trait for everything else. And I will open a pull request with this this afternoon. Oh, I did call it EQ any. Okay. Why would I have chosen that name? I could go blame and look it up. I'm sure I wrote it down. What would the alternative be? Is in? Yeah, that's kind of ugly. The reason I don't like EQ underscore any is because on Postgres we have the any operator, or the equals any operator, which is represented as EQ open paren any open paren value close paren. And I may eventually change EQ any to return a thing that automatically does equals any on Postgres, but not on SQLite. But for the time being, I haven't done that. And I would expect that I would have shied away from that name to avoid people thinking that EQ underscore any was the same thing as EQ open paren any on Postgres. But I guess I chose that name because I intend to have it do the right thing on Postgres eventually. Okay, right, so that does what we expect, because we haven't returned false for in. Right, so down here is safe to cache prepared. And that would be it. Good place to ask questions about general database stuff. You know, I mean, there's sort of the always general answers, like Stack Overflow is probably fine. You can also just hop into our DieselGetter. I know databases pretty well, so I'm happy to answer any general database questions. I might answer it in a way that pitches Diesel, but, you know. Cool. So 12:05 here. I'm trying to think if there's anything else I want to do before wrapping up. I do want to run the benchmarks again on here on master, but again, since the video encoding is taking up a significant portion of my CPU, I don't think that getting those results right now will be super helpful. You know, let's just go ahead and do it. Let's commit. I do need, okay, you know what? Let's do that before I go. I do need to clean up this function. Can I even... I don't actually think that I can abstract this away because we have this early return here. No, we can. And it's like, maybe I can pull that. I should pull that into a function, but that doesn't feel like it improved this very much. Yeah, I think this is like I'm just starting. I'm wondering if maybe I can flip these two around so that way the no caching is sort of completely separate, and then maybe that would enable me to put to remove this conditional and put it into the entry API. But then we go back into, well, now I need to have the result inside of the cache, and that wouldn't and like cleaning up the error cases there would be just as ugly as this is. Again, this code would probably just get a lot nicer in general if I had a mutable reference to self here, but I don't want to do that right now, and I don't know that I want to do that ever. I mean, this is also one of the things I've just been learning is that sometimes you will have functions that want to be slightly longer in Rust, partially just because sometimes there's a little bit more overhead to pulling out a one-off function, just because you have to write out the type signature. In the case of diesel, those can get bigger. So I think this might just be the Rubyist inside of me being like, oh, I should pull this into a bunch of one-line methods, but it's fine, I think. Yes, that is me just storing a closure in a function, or in a local variable. Yeah, I think this is pretty good. This is in a decent place. Let me just run the integration tests for SQLite once to make sure that everything is still working and compiling. And then I'm going to commit this and go get some lunch and then do the more mundane task of implementing that is saved cache prepared for every AST node in Diesel, which, trust me, it would not be terribly entertaining. While I wait for the test run, does anybody else have any other questions they wanted to ask before I log off for the day? Oh, because it's still borrowed from up there. I do something really janky where, like, I move. Oh, you know what I can do? I can just do that. And I might need to be explicit that that argument is a stir, but we'll see. (161) and 162. Yes, that is accessing the cache twice. The reason that I need to that I can't just use the entry API there is because that will what was it borrowing? Basically, it's because I need to specifically create. Oh, it keeps a borrow to the key alive, and I need to hold on. You might be right. know what? Let me get back to where things were compiling. I can get back to here pretty easily. Yeah, okay, and I'm going to do a quick commit, and then, okay, let me see. So what you're thinking is we can do something like, well, so what you're asking, I mean, we wouldn't even need the entry API there, right? We could just use get. Oh, I think I see what you're getting at, because it doesn't matter if we actually grab the entry or not. Let's do this. Let's move this into a separate branch entirely. And then this can go here. And then, okay, so if I write literally what you're asking, because it's going to complain that we end up needing, wait. Here's why. It's because I still need the key to actually construct the prepared statement, and I can't actually access it via the entry API until I get to this point. And if I use a function like get, that creates a shared reference to the cache that is alive in this branch, and so I cannot get the mutable reference I need to call the entry API down here, or insert, or any other thing that would need a mutable reference to the hash map. Does that make sense, Killer Cup? Right. So it's like it's basically a trade-off between the cost of, because the important thing is I need to not do this unless the entry isn't occupied. So it's like it's the cost between uh it's the cost between, it's just a trade-off between indexing the hash map twice versus cloning the key, basically. Which is definitely unfortunate. I suspect there's no reason that I couldn't borrow the key here. Actually, does the entry? Hold on. This feels like something the entry API actually should be able to handle. Vacant. Oh, come on, guys. Why can't that be stable? Okay, if this were if this were stable, yeah. Oh, you are literally just saying that. Yes. Sorry, I misread your saying use exactly this function. Yes, if that were stable, then I would be able to use the entry API here, but I cannot. And it looks like, oh, it's okay, so it might be stable in, what would that be? Like 2 months, 3 months? I don't know. For now, accessing the hash twice seems fine. I'm gonna leave it here for now, because I am really hungry and need to go get food. Thanks, folks. This was fun. I will be doing this again soon. I'll tweet the pull request for this when I finish it this afternoon. Have a good afternoon.